Right, here we have section 10.2, which deals with circles. So our objectives for this section, using to determine the standard and general form, the equation of the circle, and then graph said circles. So a circle is just the set of all points in the plane that are equidistant from a given point called the center. So that's the radius. The distance from the center to any point on the circle is then the radius of the circle. So here you have the standard form of the equation of a circle. So the standard form of the equation of a circle with radius r and center at h comma k is x minus h quantity squared plus y minus k quantity squared equals r squared. So the number on the right hand side is the radius squared. H and k appear with the x or y. They are the opposite of what they appear to be, however. So example 1 here. Write the standard form of the equation of a circle that is tangent to the x-axis and has its center at 3, negative 2. So I'm going to plot this first. So 1, 2, 3, 1, 2. So there's the center. Tangent to the x-axis means the circle has to touch the x-axis but doesn't cross it. So that means it's going to connect up here. So there's my circle. So if it has to reach the x-axis and it's here, that means that value is 2. That's the radius of my circle. So I need a value for h, a value for k, and a value for r to put into my equation. So h is the horizontal location of the center, 3, k is the vertical, and r is the radius. So putting this together, x minus h quantity squared plus y minus k quantity squared becomes plus because it's a double negative equals r squared, so 4. So that's the equation of the circle centered at 3, negative 2, the radius of 2. The general form of a circle looks like this. It's not nicely factored, so d, e, and f are constants. They are some number. You can convert from the general form to the standard form by completing the square for both the x and y values. So when we do this next example, we'll talk about what completing the square means. Alright, so the equation of a circle is 2x squared plus 2y squared minus 4x plus 12y equals negative 18, or minus 18 equals 0. So write standard form, find the radius, and then graph. So the first thing we need to do, if you notice you have constants here in front of the x and the y, we need to divide those out. So since they are both 2, we're going to divide every value by 2. So that gives us x squared plus y squared minus 2x plus 6y minus 9 equals 0. So to complete the square, there's a couple things to do to set up. First thing, you need to write your like variables next to each other and group them with parentheses. The other thing is you need to move your constant term to the right-hand side, so 9 goes right. Now to complete the square, you're going to divide this value by 2 and then square it. So negative 2 divided by 1, or by 2 is negative 1, negative 1 squared is plus 1. Now if I put a plus 1 here on the left, I'm going to have to put a plus 1 here on the right. I'm just going to write it up here to keep track of it. Same thing with the y's. So 6 divided by 2 is 3, 3 squared is 9, so we need to add another 9 here. So on this side, 9 plus 1 plus 9 is 19. Now, these things are now perfect trinomials, perfect square trinomials, so they will always factor as half of the middle value. Two copies of it, so that's why you get the squared. So if you think about reverse forming this, you'll have y times 3, and 3 times y gives you 6y. 3 times 3 is 9 over here. X times negative 1, negative 1 times x gives you the total negative 2x. So the center for this is at 1 comma negative 3. The opposite here, the radius is the square root of 19, which is about, let's see what the square root of 19 is, 4.4 units. So find the radius, of course, at the center, and then draw the graph. So we'll go over 1, down 3, there's the center. The radius is 4.5 units, so 1, 2, 3, 4 and a bit. 1, 2, 3, 4 and a bit. 1, 2, 3, 4 and a bit. 1, 2, 3, 4 and a half. So there's a little bit easier with some real graph paper, but that's the idea. So that's the end of section 10.2.